Cik 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 satu dua cik cik satu dua cik 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 satu dua cik 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 satu dua cik cik.
Kenapa? Setahun depan. Hmm. Enggak, nanti dibilangnya, "Wah, itu mah gara-gara."
Good morning, ladies and gentlemen. Uh, Now we have a guest from Hawaii, USA, Mr. Steve Durst, who have uh, a dream to build the observatory in the surface of the moon. So Steve Durst has already come to this institute uh, 11 years ago and also 10 years ago from here. So he is quite familiar with our institute. Now Steve will present about the next program for ILOA, and we hope that Indonesia can participate also in the moon missions. Yeah, so Steve Durst is the founding director of International Lunar Observatory Association. So Steve, the time is yours. Thank you.
Okay? All right. Exciting time for the university and changes in Indonesia, I think. So I will give you a snapshot of what we're doing and have done. As Dr. Kanjaya said, our focus is to advance astronomy from the moon. I didn't start as an astronomer. I started as a space scientist, a space explorer, and this is the path that I found our way to the moon and beyond, through the stars, through astronomy. So let's see, I have a device here. And again, I understand that you're from engineering department, from the space, the new Space Institute here, and astronomy, of course. Is that correct? Biology too, I think, and maybe geology, planetary sciences. So it's a good cross-section, good diversity. That's when some of the best learning takes place. Okay. Well, check this before. Let's see. Okay. ILOA was formed 18 years ago, 2007, as a nonprofit science educational organization in the state of Hawaii, the Aloha state, and I should say aloha to all of you. Good morning. With the purpose, like many observatories, to expand human understanding of the cosmos, but from observation from the moon, opening up a new frontier for astronomy and other sciences and activities. And we are in a very, very exciting time for space exploration, for lunar exploration especially. Of all of the functions that pioneers need to perform, if you're first, you have to be able to do a lot of things. So we narrowed down our pioneering mission to two main functions: observation, not exclusively astronomy, but first the stars, and communication, as well as contributing to the various national and international and independent commercial activity to develop human settlement on the moon, lunar-based build-out. And two advances I'll mention a little bit more detail: galaxy imaging, 21st century science education. Besides an active executive committee that meets in the Hawaii town of Kamawela, which Dr. Kanjaya has visited, besides the executive committee, ILOA consists of 28 distinguished scientists, explorers, astronomers, business people around the world, of which Dr. Kanjaya is one of them. And I think 12 of the 28 are PhD astronomers. There are 3 astronauts as well, and a variety of other equally distinguished people. We're aiming for 50 directors by the time we're permanently operational on the surface of the moon. Okay, why astronomy from the moon? And there are a lot of very, very clear, evident answers, and that's been the case since the beginning of the Apollo program. It doesn't take too much imagination for astronomers to know, or anybody interested in looking at the stars, that if there's no water vapor in the air, it certainly makes observation easier. And that's just one of the 5 items that are bullet pointed there, advantages of astronomy from the moon. A shield for radio astronomy. The moon provides, its mass itself, its shape itself, provides a shield for far-side radio astronomy. Perhaps the best place for radio astronomy in the solar system. No radio interference coming from Earth. Keeping it that way, I think, is already a challenge for many astronomers and space scientists. I think it's going to be quite a challenge, and there'll be a lot of compromises that need to be made, like many areas of lunar development, many compromises. So the idea of a far-side radio observatory Radio astronomy is a popular one. It keeps reasserting itself. There are many proposals along those lines. There has been some low-frequency radio astronomy done from the far side by Chang'e 4, the fourth China moon mission, and we'll talk about some of those missions a little bit later. The moon provides a very stable platform for interferometry, for instance, for interglobal interferometry with very long baselines. We mentioned first off the almost lack of an atmosphere, the very thin exosphere, thinner even than low Earth orbit, where space observatories often operate. So that's a great asset. 1/6 gravity. Just imagine what can be done with that physical forces. 1/6 gravity. Very large structures are very possible on the moon. And finally, we meaning we humans, Americans, Asians, Europeans, won't go back to the moon just to do astronomy. But as we go back, posting a look at is the most natural thing in the world, looking around, observing. So as we go back to the moon and build settlements servicing lunar observatories will become very advantageous compared to space observatories. It is a new frontier, and I'll make that point strongly again in a little bit, a new frontier for astronomy and other human endeavors. Again, there's one of my favorite graphics there on the right showing global placement of telescopes and observatories. You know, basically you can all kinds of observations with all kinds of in all kinds of wavelengths with all kinds of instruments are possible on the moon. Not all from the same place, of course, but the bottom of craters that provide very cold temperatures, of course, are excellent for infrared. So, as I say, just like here on Earth, as civilization and human settlement has advanced, people look up, and there are observatories all over the world. And the same will be on the moon with very favorable circumstances and characteristics to enable a new era of astronomy. What we've done, and our goal for 20 years since the beginning, has been to put as capable an observatory, capable of observation and communications, at the summit area of what's called Malapert Mountain, Malapert Summit. We haven't found another enterprise headed that way yet, even though it's widely known, studied, and researched, Malapert Summit. And in fact, it is one of the 9 final locations that NASA's considering when NASA returns people, the first woman, first person of color, to the surface of the moon, now scheduled for 2027. So Malapert Summit is where we want to go because you have 24/7 permanent observation and communication line of sight to Earth. And for our need for communications as well as observation, it's ideal. It's extremely valuable. That mountain and others in the area have high peaks that allow solar energy to be captured, if not 100% of the time, perhaps 85 to 90% of the time, and thus avoiding that one of the big challenges of lunar exploration and development, the lunar cycle with the huge temperature swings of 300 degrees centigrade. So what we want to do and what we tried to do with our first mission, as I'll show you, and hopefully with future missions, one, we want to catch the first image of the galaxy, the Milky Way galaxy center, if we can, ever from the surface of the moon. For educational reasons, inspirational, directional, the idea that that first image of the Milky Way galaxy from the surface of the moon, you know, we've arrived at the surface of the moon. Not just do we look back at Earth like we did last century with the result of the ecological environmental awareness and movement, that first image of Earth from the moon provided. But in the 21st century, we look back not just at our home planet, but out into our future, out into the galaxy. So galaxy observation, precursor astronomical observations from invited observatories and astronomers worldwide, and for Hawaii, a proposal, an example, an answer for a different kind of 21st century Hawaii astronomy that doesn't necessarily depend on building bigger and bigger observatories on Mauna Kea, Hawaii, which has limited space and limited area, and there are big problems culturally with putting extra large structures on limited areas, limited space areas. The place I'm talking about, that's Malapert Mountain right there, that highly illuminated mountain there. It's about, it's about 4,200 meters. So, besides our primary objectives, again, Earth observation, climate change, rotation of the Earth, physics that the IAU is very much involved with determining, and lunar surface support and development. And again, from the moon, any number of astronomical functions and observations, VLF, SETI, trying to observe Earth approaching objects, the killer asteroids, solar weather. And again, the reason for its value, line-of-sight observations and communications with Earth, near continuous energy, and proximity to the other developments that all of the space agencies in the world now concur that the south pole of the moon is the most immediate promising area for exploration and development. For many reasons, perhaps the first one being the likelihood of large amounts of water ice in the South Pole craters. Other advantages of the South Pole is this a unique impact basin caused by an impactor millions of years ago called the Aitken Basin crater that's 2,500 kilometers wide and a treasure trove for geologists and miners. We'll see. So, as far as ILOA 1, who will build the instruments? We're still working with our original instrument provider from our first moon mission last year in Canada, named Canadensis, as well as possible Asian instrument developers. Who knows if ITBs one day will be able to do some technical development work for ILOA, you people here. As far as how we get there, which is always the problem, in order to do astronomy from the moon, you really have to get to the moon. So it makes our mission a space astronautical mission as much as an astronomical mission. And we are talking with, there's more and more activity. There's a new company that we're talking about that just signed a contract with SpaceX, but I don't know when the Starship will be ready if you follow the news. There are a couple of other companies that last week had their lunar landers launched again by SpaceX, and they're on the way to the moon right now, taking a slow route, a slow road. So we're looking for a number of these American providers, largely US providers under the NASA Commercial Lunar Payload Services, to take our flagship to the moon. And every day that's our priority. Hopefully we'll be able to identify a provider and get building on the instruments within a month. What we have done, we worked with the first robotic telescope ever operating on another world, which was again done by China, who's operated continuously on the surface of the moon since December 2013. Not many people are aware of it, but that's going on 13 years. Going on 13 years, China's been operating continuously. Their first lander, we collaborated with the Chang'e 3, and reciprocally, we still owe Chinese astronomers a glimpse, an observation from the moon with our instrument. But we did succeed in 2014 in capturing the first galaxy spiral image from the surface of the moon with the China Lunar Ultraviolet Telescope, LUT. Right there is the LUT, 15 centimeters diameter, mounted on the Chang'e 3 lander over there, I think. That's the Chang'e 3 team that we worked with, the astronomers. This was enabled by an MOU that we signed with the National Astronomical Observatories of China in 2012. And we had a subsequent MOU that we signed with the China Space Agency the next year. And now, 10 years later, with the pandemic in between, we've collaborated, another ILOA board member, a longtime colleague, Professor Suijun Sui of NAOC, and ILOA. I worked with Professor Sui right there to hire a astrophysicist from India, from Bengaluru, Dr. Gaurav Singh, to process the LUT data. So it's a 2-year postdoc contract that NAOC and ILOA have given to. We conducted a search for a postdoc researcher, and Dr. Singh was most qualified for that position. So he will be publishing papers and giving more talks on the findings of the first robotic telescope on another world. That's what the LUT still could operate. They China turned it off. It's got a 30-year power source, but turned it off so it wouldn't interfere with the Chang'e 4 VLF observations. Okay, one more mission that we're working on is what has been come to be called ILOC, which 2 years ago our Canadian friends and partners, Canadensis and ILOA, made a proposal to the China Space Agency after there was a call for proposals for payloads on the Chang'e 7 moon lander, which is going to the South Pole. And our proposal 2 years ago was accepted, and it passed through several stages of acceptance. And some big changes occurred when the Canada government wouldn't let our friends at Canadensis provide their technology for the camera. So we've been working here in Southeast Asia, and that's what has brought me to Thailand and Indonesia and Singapore, looking for international partners to work with China and ILOA Hawaii from the surface of the moon on this pioneering astronomy project. We did find support for ILOC, not just the launch and lander, which we qualified and were selected for, but when we lost our Canadian partner through various bureaucratic considerations, we found a partner to build the instrument in a big Beijing industrial company that's built all of the cameras for the Chang'e moon landing program and the Mars lander as well, and Hong Kong University to help direct and finance the camera. But it's all Chinese until we do have a partnership from Thailand, from NARIT, and if any of you are real passionately interested in astronomy, I'd really urge you to, if you have a chance to visit Chiang Mai and the Astro Park. It's a unique treasure for humanity, I think, as far as science and astronomy goes. And we hope that along with Thailand, Indonesia, may partner with us, and we're talking about operating on the surface of the moon next year, the end of next year, which maybe is a little much, but we'll see. It's a big step, consciousness-wise, operations-wise. Maybe Singapore, and maybe we'll have a Southeast Asia partnership that ILOA has been supporting for over 10 years. We formed multilateral MOUs with Indonesia and Singapore and Thailand and Malaysia to support Southeast Asia astronomy. So this is in progress. Dr. Kunjaya knows some of the details. That is the proposed telescope that the Beijing Institute for Space Mechanics and Electronics is the name is building. And I think the flight ready model needs to be delivered in May. I mentioned we've been very active for over a decade in Southeast Asia, trying to form collaborations for science education and astronomy. This is a list of there are two significant events there. In 2022, the ILOA Southeast Asia MMOU that I just mentioned, which followed a similar one way down near the bottom in 2017. The difficulties we've had going forward is that Singapore doesn't have the same robust astronomy leadership that Indonesia or Thailand has. Singapore has commercial and communications assets that we work with. So in any case, this list of activities doesn't include 11 galaxy forums that we've had in Southeast Asia. 4 in Singapore, 4 here in Indonesia, which were all really thanks to Dr. Kunjaya and folks in Jakarta at SkyWorld. Really very interesting events. Two galaxy forums in Thailand and 1 in Malaysia. So 11 galaxy forums in that same time period. So it's a natural international collaboration for ILOA to be considering and to be looking at. Okay, here is the mission we did actually conduct. It took 16 years and 2 months, ILOX, from the idea to its realization. 16 years and 1 month was spent preparing, trying to arrange and prepare for launch. So if we can cut down that 16 years to 2 years, which is what I'm hoping, we'll have our flagship on the surface of the moon in 2 years or 2 or 3 years. There's a picture of our 2 ILOX instruments, our narrow field on the left, with a name. We conducted a naming contest throughout the Hawaii school system to name the narrow field instrument there. On the left, this pointer doesn't work too well, does it? Kaimi was the winning name, which means to search, the searcher. I think it was a 7th grade Hawaiian student that named the winning choice, Kaimi. And the wide field on the right, which also was named through a naming auction, and a Canadian scientist proposed the name of his project, Lunar Codex. The 2 instruments are a circle on the top of that 4 meter lander. A lot of people thought it was very tall, taller than most of the lunar landers, like the Apollo lunar lander. And whether its height was a reason why, as you'll see in a moment, it eventually slightly tipped over on landing remains to be seen, but it's ready for a second mission next month to the South Pole. We're not on that second mission. The company is called Intuitive Machines. It did launch after years of delay on Valentine's Day Eve on February 14, 15 last year from Florida on a SpaceX rocket, Falcon 9. And took 4 or 5 days to the moon and did conduct the landing It didn't crash like every single other private moon landing effort of the past 5 years. There were 3 others that all crashed or didn't make it. So it landed. All the machinery was more or less intact. Our instruments were not pointing in the right way. It managed to send back data from all 6 NASA instruments and all 6 independent instruments, though not full data that we wanted. But it is the first independent commercial mission ever to land on the moon. First one from USA in over 50 years. And the first one to Malapert Mountain. It ended up going to not the summit area that we want, but laterally about 50 kilometers to the side at about 2,500 meters in altitude. That's where we have 2 of our instruments. I think they belong to us, but if somebody gets there first, I don't know. But they're up there now. Here is the some of the imagery that we did capture on the way to the moon with our wide field view. I like this one because it's there we are. That's Earth. So it shows the surface of the moon, the sun, and the Earth. And coming into the landing, that's the spacecraft legs. Our camera is taking these pictures of the lunar surface. The crater on the top left on the right-hand image there, that perfectly preserved one, is 9 kilometers across, to give you an idea of this unnamed crater in the foreground. And let's see, rough landing, there we are on the surface of the moon. That's what we got. Looking at, I don't know how to do that. There's the spacecraft, and we have that's our wide field fisheye lens. Well, the spacecraft is up, you can see it on the left. That line on the lower right was the broken leg that we got a picture of, and that image on that overexposed image is the sun from the surface of the moon. I don't know if you can call it heliophysics 101, but that's what we got. A disappointment in that sense, but another picture after the off-nominal landing. Our narrow field camera did pick up some photons of stars on the star trios, and we could identify the Pleiades on the lower right, which our camera did observe. Taurus constellation that you'll see noted up there. So we had some validation of the optics on the instrument for this operation. Finish up talking about our Galaxy Forum program. I mentioned the 11 we've had here. We've had 115 worldwide. You'll see some of the cover slides of them, including one last month that Dr. Zaya and Dr. Hidayat here participated in Hainan last month. Those are some of the locations that we've been at. That was the event in Hainan, in Wenchang, where the China spaceport is growing right over there. And some of the attendees said it was exciting to see the launch site because that's where possibly the next people will go to the moon from, or from NASA, but we're on our way. So those are my comments. And thank you very much. Terima kasih, and happy to answer any questions.
Thank you very much, Steve, for very futuristic presentation for our future. Now we will enter the question and answer session. Is there any question from the floor, please?
Can I ask, how many of you are astronomers here?
Astronomers, raise your hand.
No, we met. Okay, all right.
Okay. So, ILOA has a program for taking a picture of stars, galaxies, and universe from the surface of the moon without disturbance of atmosphere. So we will have much advantage there, even compared to the space telescope, for example. We still have advantage. That is, we have a solid ground, yeah, for putting the telescope there, yeah. So the instrument will not be so complicated like space telescope, yeah. Then, okay, Dr. Kiki Virdayanti.
Okay, thank you. Hi, Steve. We met yesterday. So I would like to ask about the focus of the instrument. I mean, is there any particular reasons that you are currently focusing on the optical band? Is there any, planned timeline for reaching to more higher energy band for the instruments?
Use
A
I'm
kind
sorry.
of a roadmap to enhance the instruments to reach higher energy.
Yeah, sure. I think there are many projects now emerging on astronomy from the moon. That it was a growing field of interest up until about 1990. And the success of the Hubble Space Telescope and the change in policy at NASA, where Mars became first and you didn't talk about the moon, astronomy from the moon receded, but it's coming back strong. So as far as what ILOA can do, well, we're pretty small and it's all pretty expensive, so we're still in, our flagship is the largest instrument that we have planned now, but I think that just like Mauna Kea started with a very small test instrument and they found out how good it was, and larger instruments became desirable then. So I think that whether it's ILOA that does it or large astronomy organizations or space agencies, we will see that. We don't have one of those big projects at this point. We have these smaller ones, but the question you asked lets me make a point. We talked about, or maybe I was talking with Kanjaya yesterday about the Webb telescope and the dramatic findings and successes it's having at L2. And what we're proposing, even though our instrument is small, but the parallel with the Webb telescope is it's a new frontier that may be even more significant for astronomy than L2 is. So I think it's a good question you asked. I think there will be growth, that the moon could be the center of astronomy in the solar system by the end of this century, by 2100.
okay. Is there any other question? Okay, please, Professor Taufik Hidayat.
Yeah, I'm just wondering about the risk of the meteoroid falling from the space, because, well, there is no atmospheric advantages, of course, but meteoroids risky from.
I'm sorry, Dr. Hidayat, you're concerned about
The stone from the sky. Meteoroid, yes.
Yeah.
Yeah,
Well,
is there-
that's an obvious question, and I think that our LUT researcher, Dr. Singh, that'll be one of the findings in his report. We don't have a lot of evidence for meteorite impacts. That was the question. And looking at the surface of the moon, we know that a lot has happened. How much of it is happening at this point? We do know from the early studies of the LUT, I think they analyzed the first 18 months of data, that the degradation by meteorite impact was very low, was within the accepted limits. So that one example from the China telescope showed that micrometeorites, or as Dr. Hidayat said, rocks from the sky, is not a problem yet. It's a good question, and I guess the statistical analysis will give us a lot of information about what's possible and not, and safe and not. There are many questions about astronomy from the moon, like the dust from nearby operations, and that's going to be a big question. The contending interest between scientists and developers, just like the development of the American continent last century. There were the ranchers and the farmers, and they had to work it out.
Okay, thank you. Pak Ridanto, yeah, please.
Thank you. I'm not an astronomer. I'm sorry if my question looks stupid. In one of your slides, you show us image of galaxy taken from the surface of the moon. But in my eyes, it looks worse than the one taken from the Earth. Is that right?
I'm not sure which image that you're talking.
The Galaxy M101, something like that.
Oh yeah.
Yeah, this, yeah.
Yeah.
Yeah, this one.
Yeah. Well, the one on the right was taken from Earth. From Earth. The one on the left was taken from the moon. So we show that image on the right to confirm that that's the same galaxy, M101, the control galaxy. So if it looks the same, it is.
But the picture is better. The
picture taken from the Earth looks more beautiful.
Well, yeah, of course, and that was a much bigger instrument. Just the professor was saying, these are all first steps. That instrument there was 15 centimeters.
15 centimeters.
May I have another question?